So in the processing step, we do a number of things. We do the data cleaning, we do data transformation, and we apply a few techniques from what we call feature engineering, and I'll talk about that in a little bit. So let's start with the one that we're kind of more familiar with, which is the data cleaning step. But before we do that, there's one thing that we need to pay attention to. We only want to apply the transformations to our predictor features, not to the target one. For example, if we scale our features such that they only range from 0 to 1, we don't want the same to be applied to our target, because at the end of the day, that's what we're trying to predict. That's the actual value that we want to get out of the model we're building. So to do that, let's separate the target from our original dataset. And to do that, I'm going to create a housing X. That will be our inputs, and that will be our strat training set dot drop, and I'll specify the column that I want to drop here, which would be the median house income, or house value, sorry. And we'll do it on the column axes. Same goes for our labels or our target. So here our housing Y would be our strat training set, and this here would be our median house value dot copy. We take a copy such that if we do anything to that variable, we're basically not modifying the original stratified training set here. Now we're ready for our data cleaning. We remember from previously when we did the info call to our data set, we found that we had a number of missing variables in our total bedroom column. The numbers are obviously different right now because we're only looking at the training set of the data set that we have. So when we talked about handling missing values, we said that we have multiple options. Either we drop the rows or the records or the districts that have the missing value. If the feature itself is not that important, we can drop the entire column, or we can calculate a central tendency measure and substitute the empty values with that central tendency value. So our first option, which was to drop the empty records, we could do housing X dot drop NA, and then you need to specify the subset that you want to look for the NA values in. So in this case, that would be our total bedroom. Or our second option, which is to drop the entire column. So here we do drop, we specify that we are dropping the total bedrooms at the column axis. Or our third option, which is the one that we went with and the one that we were gonna want to go with as well in this exercise, which is to calculate the total bedrooms median, and then fill the NAs for our total bedrooms field with that value. Let me actually comment these out so I don't forget and run them by mistake. Now this median that we've calculated, we need to store that variable somewhere or retain that variable so that we can apply the same transformation to our test set. Right now, that median, that value that we've calculated for our median, it was only calculated based on the training set. However, we still need to maintain the same value and apply it also to our training set and to any new incoming data that we receive that might be missing this value. Now, I'm not going to run this cell because I want to show you a different way, because we've already talked about how we can do this before, and that is by using a scikit-learn package or a class called imputer. So from sklearn.imputer, or I think it's just impute, I'm going to import simple imputer. We'll instantiate this class, and we need to specify what is the value that we'd like to replace missing values with. So we basically define the strategy, and in our case, that's going to be the median. And like we've said before, calculating the mean and the median, all of that kind of stuff, only really makes sense on numerical values. And so because we have a categorical value here, which is our ocean proximity, we're going to need to remove that feature so that we can apply the imputer, and then we'll put that feature back in again. So I'll create housing X num for numerical, and I'll just basically set it to housing X after dropping the ocean proximity column. Now, similar to the linear regression class that we've used in the previous module, we also need to train this imputer here, or basically fit it to the data that we have. So we say fit, and we're gonna provide our data set, which in our case would be the numerical x, and that's it. We can actually see all the median values that it was able to calculate for us by getting the statistics parameter here. So if I run this, you see this array. So basically for each one of our columns, it calculated a median value that it will retain in the model itself, so that whenever we want to apply the same transformation, we just call that same imputer function. So now we can use this trained imputer here to transform our data set. So I'm going to call imputer.transform, and I need to provide our housing x numerical. Actually, let's save that into a variable. So here's our x. Now our new housing x numerical transformed is going to equal to, I'm going to call pandas. We'll create a new data frame, and I'm going to provide the x as my input. We'll set the columns to be the housing numerical values columns, and we'll also set the index to use the same index from the original housing numerical values. Now, a few things to notice here is, one, we dropped or we separated the categorical data into a separate data frame, and we also removed the y or the house value into a separate data frame that we'll come back to when we actually do the training of our machine learning model. Now, one other thing to notice here is that with all the scikit-learn packages, classes, functions that we've used, you can notice there's a little bit of consistency across the board. Every time we want to use any of those estimators, predictors, or transformers, we instantiate a variable that holds that function. We fit that model, or we train that model using our data, and then we use it, whether it's a prediction, so we use the .predict, or it's a transformation, and so we use the .transform. Also, you'll learn that we could have done both steps in the same time. So we could have said that our x equals imputer fit transform, and let's remove this here. And that's basically combining the two steps. I could remove this as well. And this would do the same job essentially. If I run this, then follow it up with this and getting the head, the data is the same. So you could use either the fit first and then the transform, or you could do the fit and transform at the same time. Because most of the machine learning algorithms we use are expecting numerical data for them to be able to perform all these calculations, we need to figure out a way to how to transform our categorical data into numerical data that we can apply some mathematical operations on. So we'll stop the video right here, and we'll talk about that in the next video.